In this video, we're going to be using matrices to solve linear equations. We'll use row echelon form to solve. In other words, we're going to make the matrix into a row echelon form. We can manipulate a matrix by 1. We can multiply or divide an entire row by C, where C is not equal to 0. We can interchange two rows, or we can add or subtract one row from another row. Okay, now we're going to use augmented matrix in row echelon form. So augmented matrix is where we are going to have, we have the numbers here to the left, and if you notice along the diagonal, we'll have numbers, but below that diagonal, we're going to have zeros. Okay, so similarly over here, there's another form. We're going to have zeros below the diagonal. Okay, and we'll have our solutions over here. Okay, so let's get into doing an example. Okay, so for example, if we're given this system of linear equations, okay, so first we're going to put it into a matrix form. So putting this into matrix form, here all the x values would be 2, 1, and 2. So all the coefficients of the x's I'll list off here, then all the coefficients of the y's, then all the coefficients of the z's. So we have 1, minus 1, plus 1. And then we'll have our solutions, 3, minus 2, minus 1. Okay, so now we want to have this diagonal, but everything below the diagonal we want to become 0. Okay? All right, so all these numbers here, I want to become 0. Okay, so first thing that I'm going to do is always better to have 1 in the pivot point. So I'm going to interchange row 1 with row 2. So interchange row 1 with row 2. So this creates 1, 2, minus 1, minus 2. And then we're going to have 2, minus 1, 1, 3, and then third row stays the same. Okay, so I'm going to use this here as a pivot point. Okay, that's a pivot point because that number is going to remain, whereas all the numbers below is going to turn into 0. So I could multiply row 1 by minus 2 and add it to the second row. And to save time, I'll do the same thing to make the third row 0 below the 1 in the first column. So I'll do minus 2 times row 1 plus row 3. So these are two separate instructions I'm applying. So we'll have 1, 2 minus 1, minus 2, Okay, so this first instruction, minus 2 times 1 plus 2, that give me 0. Minus 2 times minus 2, that'd be minus 4, and minus 1 would be minus 5. And minus 2 times minus 1 becomes plus 2, plus 1, that'd be plus 3. And minus 2 times minus 2, that'd be plus 4. And 4 plus 3 is 7. Okay. And then let's look at the other operation. So this other operation I'm doing now. So minus 2 times 1 is minus 2, plus 2, that'd be 0. Minus 2 times minus 2, that'd be minus 4, plus 1, that'd be minus 3. And then minus 2 times minus 1, that'd be plus 2, plus 1, that'd be 3. And minus 2 times minus 2, that'd be plus 4 minus 1 will be 3. Okay, so I performed those two operations. Okay, so next thing I want to do, so I've created zeros here and here, which is what I want to do. So the next thing I want to do is to create a 0 here, right? So I'm going to multiply the second row by, so I make it a minus 3/5, and then add it to the third row. So the first row is going to stay the same. The second row will stay the same. But now the third row, minus 3/5 times 0 plus 0 is 0. Minus 3/5 times minus 5 becomes plus 3. And plus 3 and minus 3 becomes 0. Minus 3/5 and times plus 3 becomes minus 9 over 5. And minus 9 over 5 plus 3 will give us, so 3 could be, so we have minus 9 over 5 plus 3, but 3 could be represented as 15 over 5, so we have 6 over 5, and then minus 3/5 times 7, that's minus 21 over 5, plus 3, which is 15 over 5, so this is minus 6/5, okay? So now recognize that this represents the x coefficients, this represents the y coefficients, and this represents the z coefficients. These represents our solutions, okay? So starting with this row, starting with that third row, we would have 0x plus 0y plus 6/5 z is equal to minus 6 over 5. So right away, these don't matter. So this implies that z is equal to -1. Now that I know that z is equal to -1, I could go to the next row up. So I'm going to go to this row. So I could say 0x minus 5y plus 3z is equal to 7. Well, we know that z is equal to -1. So this means that minus 5y plus 3 times -1 is equal to 7. So if we have minus 5y minus 3 is equal to 7, So we could add 3 to both sides. So that would give us minus 5y is equal to 10, which implies that y is equal to negative 2. Okay, so we have this solution here. We have this solution here. So finally, we could go back to the first row. Okay, so the first row says 1x plus 2y minus 1z, you could say, okay, is equal to minus 2. Okay, but we know that y is equal to negative 2 and z is equal to minus 1, and all of that is equal to minus 2. So we have x minus 4 plus 1 is equal to negative 2. So minus 4 plus 1 will be x minus 3 is equal to minus 2. So we'll have, this means that if we add 3 to both sides, we're going to get x equal to plus 1. So we have our solution set. We have 1 for the x, minus 2 for the y, and z is equal to minus 1. Okay, that's it for this video. Thank you for watching.